All right, I see some people joining into today's webinar. So Simon, we'll give it a minute or so. Everybody has to install a Zoom update every time they join in. Then you got to add some new permissions.
Sounds good. All right. Sorry about the pain, everyone. You're going through just accessing Zoom.
So we'll give it a minute as people join and get those Zoom updates going. All right, we're at about a minute past, so I figure we can get started and start talking about code inventory. Thanks for coming, everybody. My name is Eric Kostler. I'm on the Azul product management team, and I helped release our new code inventory feature, which should help you have some things in terms of selling both the Azul code inventory capability, as well as your ability to offer services for your own company beyond what code inventory does, so that you can have additional upsells for yourself with the data that's generated by this feature. Some of the challenges that people have that code inventory is designed to solve is that a lot of the applications that your organizations create for that custom software and those custom pieces of work that they create themselves is that they only make it once. And the majority of their time is spent maintaining that application. They're adding new features, they're fixing bugs, they're updating libraries, they're doing some work. And you want to spend your money wisely when you have to go through and work on a large application and pay quite a number of developers or contractors to work on it. And as people go through to work on their applications regularly, one parts of the maintenance that they have to do down in the bottom right there are they periodically have to update different libraries. They periodically have to go from one version of Spring to another version of Spring just to keep pace with the times. From a Java perspective, oftentimes they have to upgrade to a newer Java version that came out. For example, Java 21 just came out a week or so ago. Maybe people are going from Java 8 to Java 11. Maybe they're going from Java 11 to 17. Maybe they're going from 17 to 21. It's just a regular activity that all of your organizations and customers are doing with their custom software. And really, over the time, they get a series of unused code that builds up, and the time that they spend working to update that unused code is really just a complete waste of time, because all it does is burn billable hours from their development departments to update it, but that code never actually runs. So the sooner you can get rid of that, the sooner you can avoid people's waste, decrease the cognitive burden on your development teams, and improve your applications. Now, the way that this stuff builds up over time is that when there's unused code in an application, it really increases the maintenance burden that these organizations are doing to pay their own development staff, to pay their contractors to work on their applications. Now, let's say hypothetically that your customer has a unique piece of software that they build for themselves to run their business. And let's say they did a perfect job when they first started. There's zero unused code in that application. The organization is lean and mean. Every developer that they've hired has brought their A game, and their application is perfect. Over time, they have to do maintenance work to that application, which means they go to upgrade their Java application or their Java instance. They go from Java 8 to 11. They change some features. They start adjusting the way that the application works, and they update some libraries. Over the time, just as part of that general maintenance, what happens is you comment some lines out, you change some bits of flow in the application, and you start building up these small portions, those pink items there, of code that is in your application that really just clutters up your code base that you're constantly navigating through. But you're adding new features and things, so that's okay. We got to deliver value to the business. And you know what? A couple years have gone by. We've been really successful. We're still working on this application. It's time to go from Java 11 to Java 17. Well, now over time, they've built up some more unused code. And the problem is each time they do that migration between the circles here, when they say we have to upgrade from Java 11 to 17, you don't get that for free. You have to have a member of your staff do it. So they go through and they end up having to actively patch and actively work on and actively migrate the code from that version of Java, even though that code is completely unused in the application. So ultimately, the organization has two choices. One is they can remove the code, which they're hesitant to do, or two, they can spend a lot of money for their development teams to go through and patch the code, even though it never gets used. And of course, if that's the decision, then shouldn't I just get rid of my unused code? Well, simply put, the majority of organizations aren't actually doing that today. And as we talked with them, they're all hesitant to go through and remove code from their applications. Well, why aren't they taking what is to us the logical choice of get rid of that thing and decrease my maintenance burden? The reason is that picking out what portions of code are used or unused is really not as obvious as it sounds. There's no apparent way of looking at a piece of software until now and determining, yeah, you know what, I can get rid of this. I don't need to spend, 4 hours updating that code and making all of its unit tests pass. I can just get rid of it. And the gist is there's a big consequence when people do that and do it incorrectly. If I go through and I take out a portion of my application and I say, I think that code's unused, so I'm going to remove it. If I'm wrong, there's a big consequence of me breaking the app or making a bunch of my unit tests fail. So really the consequence of being right in here is okay, but the consequences of being wrong are high. And they take a huge amount of time and money. It is a real pain to delete code from your application. But with code inventory, what we offer to let them do is to really track the execution of all their live code from their production environments so that we can tell you exactly which methods ran. So as you go to look at your code base and as the members of your customers' development teams are looking at their code, they can say, oh, I'm interested in removing this method because I don't really know what it does and I wish I could just get rid of stuff. I'm going to go check code inventory and see if it ran. And if it's not in my inventory, then I'm going to say that it didn't run. And that's where I'm going to get the confidence to be able to remove it. So what happens is we've taken all the difficulty and all of the situations where you're really low confidence of saying, I don't know if I can remove this code from my code base or not. And all of a sudden, it becomes really easy to be right. So, technically, there's still a consequence of being wrong, but it's way easier to be right. And it's a little harder to be wrong because if we tell you that that method has been used, you know what? You shouldn't remove it because you actually use it. So it really simplifies their work of identifying what they can remove. Now, we give this information down to what's called the method level, which is the individual functions that all that company's developers are writing as they hire their development staff, their contractors, their full-time employees. Those developers are writing methods that make the Java application work. And we will give them a report down to the individual method level that says, yes, you are still using this. Or if you have a listing of your source code and you look at code inventory and it doesn't appear, then you are not actually using that method and it is a candidate for removal to decrease your maintenance burden. Our record is accurate simply because we repurpose the fact that the JVM goes to load someone's code so we can tell you definitively that that method has run. It's not a hypothetical evaluation of, yes, this code looks live. We literally watched it run and the JVM went to execute it. And we do this because we're able to monitor an organization's production environment, which is giving them feedback from their actual customers that they can take back during their development cycles, their agile sprints, to reduce their future maintenance cost of this application. Now, the big benefit of being able to monitor this stuff in production is it'll help a lot of the organizations who, over the last 10 years or so of test-driven development, have gone through and built up a huge battery of tests that they have to get a green bar on all their applications. Well, a lot of organizations do have a lot of these tests, and we could be in a situation where it turns out those tests, which are very time consuming to write and manage, are the only thing making the code execute and stay alive. Well, now you've got kind of a double cost there. But if you watch your production environment and you say, why am I spending a lot of time and money testing this code when the code never actually runs in production? You're able to reduce the maintenance burden for those people because you can get rid of both a lot of code that's a part of the application that takes up a lot of mental load from their development teams, as well as reducing their test cost, which is an ongoing, just general part of software development in order to help that organization reduce their costs of maintaining an application, which is really the bulk of a cost for an organization as they put together their own custom software. Now, the way the code inventory works is we've gone through to repurpose the JVM's first call optimizer. So the first time that the JVM warms up and says, I'm starting to execute your code, I'm going to make your application run really fast, we just export a bit of data that says, here are the following methods that have been called. So from their applications running on top of the Azul JVM, that's how we get the full accurate record. And there's no performance hit because the JVM already is about to do that first call. Now it just makes a record of it that it sends off to a central location identified in point number 2 there, where that customer's individual Azul tenant captures all of that data. And it's really important to capture that data in a central location like we have here, because a lot of the times these organizations will run their application on a virtual machine on a container or a different one each time. Well, if you just go to look at each of those containers or virtual machines in an isolated capacity, you won't see the time where a different execution of the application did call the function. So by us gathering that information together in that central point of information, first, it's a single tenant dedicated to your customer that you can also look at to help your customer with their code inventory and to help guide the services that you sell to consume the data. Then the app owners or you can go through and look over that code inventory data and help figure out what part of the application they can engage with and really remove from their code base to reduce that maintenance cost. So for you being able to sell services, one of the things that you can do is to say, we're going to watch your application. I'm going to help you spin up this data gathering piece. And then we're going to help you figure out how you can reduce future maintenance cost of your application by not having to scroll through that code anymore. So one, that value decreases the maintenance burden. And two, as the organization onboards even their own FTEs, or as you guys discuss billable hours for future things in the future, just work that you can help them with, there's no more need to constantly scroll through that code that was deleted because you've helped clean it up. Now, the way that we present this information to the organization is we identify the code based on source name, which is a jar file, really just a package container for where the code is. We give the class name so that you know where to look, and then the specific individual method. And we have a first seen there in terms of when that method was first seen. And then over time, as the application starts running in different areas, we continually update this last seen date right there. So if an organization has tried to deprecate a method, let's say they're trying to turn a feature off, they're trying to turn a capability off, or they're saying, I think this might be unused, and I think that might be a candidate for removal, you can go and continually watch that last seen date. And if that last seen date is something that feels relatively recent, like it's within the last 2 weeks or 3 months or 6 months or years, you should just keep that thing hanging. You should keep that as part of the application and not remove it. But when the last seen method starts falling back in time, that's a candidate for removal from the application, because you can look and you can say, I am tracking invocation mechanisms from this application, and I'm not seeing that method is running anymore. So I'm going to clean it up. And now next time we scroll through that file, next time we go to work on the application, we won't have to do that anymore. Otherwise, we have to bring this information together, because every application that an organization writes or runs has a huge number of methods to it, even simple basic tests. You can have an application that very easily has about 14 or 60,000 methods. So we have to bring those together in order to consolidate them, or the data is just too big. Now, there are some tools that organizations can use today in order to help remove what's called dead code, but there's a big difference between dead code that these static analyzers can find and unused code that Azul can find. So the static analyzers will go through and they'll find things like, this method is private, so I know for a fact that this private method can only be called from within this class, and you don't call it. Therefore, this method here called private void only from here, that code is dead. And the static analyzer is right. But the static analyzer cannot determine if Pojo handle request is called because it has a public modifier, if public void from anywhere. The static analyzer can never report on that. Or what if I could just completely remove this entire file? So we can see there's a comment there that says / at post. That's a signifier that something has been commented out, that little / in the beginning. And somebody worked on this application and just commented that out, which means that the handle request method is no longer going to be called. So because Azul's new code inventory feature watches the application run and records what ran, what happens is you'll stop seeing that handle request appear in your code inventory, which means we can track all of the organization's code for their application to help them figure out what they can remove. Now, some common questions that we get are, will this extend to third-party libraries? We can help organizations with third-party libraries, but the information is a little less actionable because we're really focused on development organizations that produce their own Java software and helping them figure out how they can clean that software up a little bit. We summarize all of the information for their JVM runs so that they can get a clear picture of what they can do. And we're very different than the static analyzers or IDE-based tools that they're using today, because we can scale to their entire project, and we don't just track dead code, we track unused code as well, which a static analyzer can never find. All right, Simon?
Great, thank you, Eric. Hi everyone. Just to finish up this session today, I wanted to get into a little bit about sort of what's in it for partners here, because as we started to pull together our go-to-market on code inventory, it became very clear that a lot of partners provide services in some of these areas, and particularly as it relates to efficiency on those services. There's usually a lot of effort in going to find out what's involved with code cleanup and code review, just from a resource-intensive perspective. And what was obvious was that there are a number of projects that partners get involved with customers, and those customers just don't proceed because the cost that's associated with doing the code review and code maintenance is considerably higher than they anticipated, and they just don't move ahead. So these things just don't get resolved. So if you think about the ecosystem that relates to the way partners interact, and you interact with your customers off of what Eric's been talking about, there's quite a few things here that we can talk about, and I want to build this out a little bit. So we've been talking about code maintenance and integrity review of code and how that relates to code relibraries, and the alternative, which is to use code scanning products, which often don't find or provide the level of detail certainly that we now provide with code inventory. That's really the software supply chain. But then, of course, on the backside of that, there's really more the liability side, which is let's get rid of the redundancy of code. Let's look at whether that's creating security potential issue. Of course, unused code and code that's not running obviously has less of a security impact, but still it's a footprint and it's consumed by the application. So, there is a level of potential concern around that as well. So we see this all as part of a similar ecosystem because, as you'll see in a second, code inventory is built into our AVD technology. That's Azul vulnerability detection. And as we price this and you see what the opportunity is, there's really a nice connected journey here between taking the customer conversations, one on maintenance and code review, into ones that are more security related, so that you can create that not only linearity around services, but you can get into more of the upsell around our platform core, for example. So with that, let's just talk a little bit about what this looks like, because people ask me this all the time, which is, okay, this is great, Simon. What's in it for us as partners? How do we go and monetize this a little bit? So if we take an example of which is a small 2,500 vCore opportunity with 1,000 desktops on Azul platform core, which is basically an Oracle switch from an Oracle Java SE license model. That particular type of deal for the customer is going to cost them around 78,000, something like that. As a platinum partner, you make 33 points on that. That's what we publish in our partner price book and also in our partner program materials. And therefore, you're going to make a considerable amount of money off that initial deal. The goal, though, really is to go back to some of those opportunities. And even if you're doing a prospecting in that context, there's no downside to positioning code maintenance and code review as part of that switch, because let's face it, to use Eric's analogy, if you were moving house and you were switching from Oracle to Azul, or you were thinking about packing your garage up and moving your house with your garage and putting that in the next place, you're not going to take literally all of the trash that you have in your garage and just go and push it all into the next garage where you move. You're going to clean it up. So a level of code management, code review and cleanup, it happens in every migration exercise anyway. So there is some logic around this, or at least in a very short period of time. So if we look at the upsell opportunity, and let's just assume that we take that initial deal and then 6 months later, we go and say, okay, well, there's an opportunity for code inventory, which is in AVD, for example. That's the way we bundle it. And it creates another opportunity around, typically in this case, about another 54,000 of opportunity. We co-term to adjust so the customer resets their subscription period. You're going to make some considerable money on that as well, another $30,000 from the 25K. And then let's just assume that after that, you do a 3-year renewal. When that comes around, there's another 130,000 to be made over the overall deal. So just with this one scenario of thinking about switching to Azul platform core and then upselling the code inventory stroke AVD capability, which is the same technology, you can get a significant amount of opportunity just from one deal. And it's not something that it's just comparative to, say, using a Red Hat or using a Microsoft, using an Oracle typical OpenJDK. This is all incremental stuff that really is highly oriented to production. It's highly oriented to value above and beyond just providing support or around a JDK. So lots to think about here, but this is on the license side. Now, if you think then about services as a pivot off of this, what services could potentially we get into? Well, there are really 4 areas. Now, many partners are currently doing this today. Some of you don't do this and could do this, and it's a natural extension of advisory. So if you think that you do a Java license advisory, and then you might do a JDK recommendation advisory, or you might do an advisory on migration, which could be the project management side of a migration, or even the migration itself, right? Natural extensions to that are code review as part of a migration, identification of the quality of code, whether you're using a scanning product to use something like CI, code inventory, and then ongoing maintenance of that, because this isn't really something that just happens once. Anybody with any real estate of Java applications, they're going to be doing this constantly. It's a cycle of evolution to manage and clean up applications as they go through maintenance and review and enhancement and updates. So there's a great opportunity to embed this as part of, for example, an Oracle a license defense strategy, where you would do an advisory annually and you would build in, additional services around management of code or review of your code, because we're providing all the reporting intuitively, so it can be much more intelligent about the way you approach it with customers. So we think there's somewhere between 10,000 and probably 40,000 US dollars for each one of these steps, depending on how much of it you get into as you go and sell that. So that's probably around 50% of additional services opportunity around the license opportunity, just by looking at the code inventory side of a Java application. Now, with that, I think, to be fair, I've probably got to the end of the slides now, and we're almost at time. Just going to check to see if there's any questions. I don't know if, Eric, if you're still on a second. I'm assuming you're still there, Eric, because I've noticed there's a couple of questions here.
Yep.
So one of the questions that pops up, and I think somebody just mentioned this right now, is what is the infrastructure required to support code inventory? Is it something that's really simple? How easy is it to set up?
Yeah, give me just a second to go back, because we had it and I talked about the role of a single tenant. So whenever you go to sell a piece of software to an organization or a customer, you always have to have some sort of setup that you do. But ultimately, code inventory is a SaaS service. So within a customer's environment, the infrastructure that they need is really what they already have, which is they run their applications on top of the Azul JVM, which hopefully they're already doing today. And then they send that through effectively a proxy thing that they have called the forwarder. So you set up the forwarder, and then Azul, we will manage the cloud processing stuff and all the things for their tenant. So really, there's only one thing that you have to set up within an organization, which is that forwarder. And it only needs to be set up once per major environment. So that's really it.
Cool. Thank you very much, Eric. Hopefully that answers the question. If anybody else has any other questions, just please feel free to fire them in the Q&A on Zoom. Oh, I've got another one here. You mentioned dead code and unused code. Remind me again, Eric, what's the difference between the two?
Yep. Give me just a second. Yep. There is a big difference between the role of unused code and dead code. Dead code is what's called code that is completely unreachable. Like there is no possible way that that code could ever execute. Because, for example, right here, I had the slide where it was marked with private. Yep. So the code that's marked as private there, there is only one location from which that method can be called. If it's not called, I can say that that code is dead. Unused code is just code that could possibly be called, but isn't. It never runs because maybe I figured out a better way to do the method and I did that other method and I just never removed my original implementation. And it's this unused code that builds up all the time because people comment things out. They change a method, they adjust something. The annotations change. So it's not the dead code that builds up. It's the unused code of like, well, I don't really want to throw this thing away, so I'm just going to keep it here. It's effectively that box of cables that a lot of us have sitting in the closet somewhere where every cable belongs to a thing, but we don't really know if we still have the thing, but we keep it around anyways, just in case. And another cool thing about removing unused code is that all these companies, it's not like they remove it forever. It's still there in their version control repository. So like if they ever really said, you know what, I really, that piece of code was sentimental to me and I wish I hadn't removed it, they can always go get it back from their version control history. But when you remove unused code, it just doesn't clutter up your space all the time. It's much easier to work around it.
That's great, Eric. That helps clarify a lot. Thanks for that. So just in the interest of time, one last question has come up here, which was, can partners sell this today? Yes, you absolutely can. So we didn't need to do anything really to update how you can sell this today, because it's already embedded in our Azul vulnerability detection pricing. So if you're selling that product, the code inventory is embedded in that product. So that pricing exists on our price books today. It's available for distribution and resale. So you have complete option to go and immediately add that onto an existing customer engagement, and or help you position that as you're trying to sell a platform core, for example. So with that, I don't think there's any more questions. Eric, are you aware of any?
I don't have any, but if anybody needs any questions, feel free, reach out to myself, Simon, or Matt, and I'd love to help you and your customers succeed and do well.
Right. Well, thank you very much for everybody taking the time, and yeah, catch us on the next webinar soon. Appreciate it. Thank you.